All right, hey again, AP Chemistry. This is going to be part 2 for quick check number 4. Very important quick check because it's a lot of new information and a new type of procedure in doing calculations. So again, if you're the type of person who doesn't need to watch the entire video and you could just copy and watch through, you could do that. Otherwise, you might want to pay attention to my explanations. Or if you copy it and you're just like, wait, why did he do that? You could follow along and find my explanation. So Hess's Law gives you these delta H's of formations. These are known quantities. These are things that are going to be given to you or something that you could solve for given enough information. So I could use these to solve for the delta H of any reaction. So given the above delta H's of formation, calculate the delta H of combustion of pentane. What's going to be huge, and I'm jumping down here, is how we write combustion reactions, and that's from chapter 4. So you're going to have to know how to write combustion reactions. That's coming from chapter 4. And so basically the way that we write combustion reactions is CaHB, some hydrocarbon. Hydrocarbon means hydrogen and carbons. Plus oxygen yields CO2 and water. That will always be the three parts of a combustion reaction. I add oxygen and I get carbon dioxide and water. And then the last step is up to you, is balancing the chemical equation. So the question says, what was big here is you have to write the combustion reaction for pentane, which is C5H12. So like I said, it's CaHB plus O2 yields CO2 plus H2O, and then you have to balance. So C5H12 plus 8, well, I didn't do 8 yet, plus O2 yields CO2 plus H2O. And so you just write that out. I didn't know the coefficients yet, right? The coefficients will come later, right? And then once you write all of that out, right? So the skeleton would have been C5H12 plus O2 yields CO2 plus H2O. And then it's up to you to balance the chemical reaction. So my tip is first balance carbon, then hydrogen, then oxygen, right? So I have 5 carbons on the left. I only had 1, so I had to put a big 5 in front. I have 12 hydrogens on the left, and I only had 2 over here, so I had to put a big 6 in the front. And then for oxygens, I only had 2 on the left, and I put 5, 6, so I have 5 times 2 is 10, 6 times 0 is 6, so 10 and 6 is 16. That's why I put a big 8 on the left side. Okay? Now, you need to go back and remember how to balance chemical equations and writing combustion reactions. You might need to replay how I wrote a combustion reaction. But again, combustion is O2 plus CO2, H2O. And then I have to balance. Remember how to balance. Then if I want to calculate the delta H, I drew this down here. There's a specific equation that you got from chapter 6. The delta H of a reaction is going to be the sum of N times the delta H of formation of all the products minus the sum N times the delta H of formation of all of the reactants. And I have all of the delta H's of formations up here for anything that I could use in this question. So here are my products. There's 5 CO2s and 6 H2Os. Here are my reactants. There's 1 C5H12 and 8 O2s. So I have to do 5 times the delta H of formation of CO2, 6 times the delta H of formation of H2O, minus 1 times the delta H of formation of C5H12, plus 8 times the delta H of formation of O2. And then I made a note here that the delta H of formation of elements in their standard state is equal to 0. Therefore, the delta H of formation of O2, which is an element in standard state, is 0. So I just made a note there. It wasn't given in the table, and you will never be given the delta H of formations of elements because it's going to be 0. So if it's not given, typically it'd be 0. And then if I follow through with the calculations, I do 5 times the delta H of formation of CO2, so 5 times delta negative 393.5, plus 6 times the negative 241.8, minus 1 times the negative 173.1 plus 0. And you should check my math. You get negative 3245.2 kilojoules per mole, which is pretty sweet because it matches very closely to the answer we got in the previous question for the combustion of pentane. And then I'm going to end here where I did another question where I wrote out another combustion reaction. C2H5OH plus 3O2, 2CO2, 3H2O. Convince yourself how to write a combustion reaction. Again, you add O2 and you get CO2 plus H2O. And then you have to balance. Okay? Balance carbons and hydrogens and oxygens. And then I just plugged and chugged into the equation, and I got negative 1,234.8 kilojoules per mole. So you should check to make sure that you get the same numbers when you do this on your own. All right, so this is a quick video for quick check number 4, part 2, using Hess's Law. We will get questions on our quizzes and on the AP exam about using delta H's of formation to solve for the delta H of a reaction.